Unacademy. Let's crack it.
Hey everyone, a very warm welcome back to the channel. So today we have a very interesting question from the house of trigonometry, in which we are being given that if alpha, beta, gamma do not differ by a multiple of pi, and if the following all expressions are equal to k, then we have to find what is the value of k. So the maximum time allotted would be 6 minutes, and ideally you should try to do it within 3 minutes. So pause the video, give the question a try yourself, and then return back to have a look at the solution. So I hope you all have tried. Now, as far as the answer is concerned, the answer would be plus or minus 1. Concepts and formulas that have been used in this question are that if tan x is equal to tan y, then we should know that y would be equal to x plus n pi or y minus x. The difference would be a multiple of pi. Okay. And we should also know the simple expansion formulas of cos of a plus b and sine of a minus b, like cos a cos b minus sine a sine b, and sine a cos b minus sine b cos a. Very basic formulas that everyone knows. Now, let us have a look at the solution itself. Observe that alpha, beta, and gamma all satisfy the given equation in X. Now, this is probably the most important part in the entire question, because after that, the question is pretty easy. So, observing this fact probably might have been the toughest thing for the students to do. Now, the thing is that alpha will satisfy this equation in X, beta will also satisfy, and gamma will also satisfy. Now you might ask, or you might be wondering why. I'll tell you. Look, S I have defined as alpha plus beta plus gamma. Now what we have done is that in these given expressions, we have written beta plus gamma plus alpha minus alpha. This gamma plus alpha I have written as plus beta minus beta. So basically we are creating the S and then minus alpha. We are creating the S and then minus beta. In that fashion, we are continuing this. Okay. So for example, if instead of X, if in place of X you put alpha, what do you get? In the numerator, you get cos of alpha plus theta. And here also we are having cos of alpha plus theta only. And when you put alpha here, what is S minus alpha? Clearly it would be beta plus gamma from here. S minus alpha would be beta plus gamma. So in the denominator we get sine of beta plus gamma, and sine of beta plus gamma is the denominator in the first term, and that entire thing is obviously equal to k, and here also that is equal to k only. So indeed alpha satisfies this equation. Similarly, if you put beta, you will see that it generates the second equation. Okay, cos of beta plus theta upon sine of gamma plus alpha is equal to k. And similarly, when you put gamma, it generates the given third equation. So that's the reason why we are saying alpha, beta, gamma all satisfy this particular equation in X. So I hope this point is clear. After that, the question is easy. We have simply cross multiplied and expanded cos x plus theta as cos x cos theta minus sin x sin theta. And sine also we have expanded sine of s minus x. We have expanded as sin s cos x minus sin x cos s, and we have multiplied by k. After that, what I've done is I have collected the terms inside of sin x by taking sin x common from this term and this term, and I have taken cos x common from this term and this term. So basically, we have rearranged in this manner, right? Now let us assume that this quantity is non-zero. If this quantity is non-zero, then we can divide by this. Okay, like division would be allowed then in this manner, right? If this is non-zero, right? And I have also divided by cos x. So we basically get tan x is equal to this quantity upon this quantity. So k sin s minus cos theta upon k cos s minus sin theta. Simple thing, just we have done division here, nothing else. Now let us call this quantity as lambda. And lambda is obviously a constant because k is a constant, s is a constant, theta is a constant. Basically, x is the only variable which can take three different values, alpha, beta, and gamma. So this is a constant, right? So tan alpha, since alpha, beta, gamma all satisfy this equation in X, we can say tan alpha would also be equal to lambda, tan beta would also be equal to lambda, and tan gamma also equal to lambda. So clearly they all are equal and equal to lambda. So this would imply alpha is equal to n pi plus beta is equal to m pi plus gamma, which is a contradiction, because in this case, alpha and beta would differ by an integral multiple of pi, which is given in the question to be not the case, not to be the case. So that's the contradiction, because alpha, beta, beta, gamma, gamma, alpha cannot differ by an integral multiple of pi. So our initial assumption must have been wrong. And when we assumed that this was non-zero, this must have been wrong. So it must have been equal to 0. So that's what we have written here. And since this quantity is 0, this entire thing becomes 0. So this also must be equal to 0, right? Then only it will be equal to 0. If LHS is 0, RHS would also be 0. And clearly all the cosines can't be 0. So this only has to be 0 in the product. Now, so we have written k sin s minus cos theta is equal to 0. So basically now we get k cos s is equal to sin theta, k sin s is equal to cos theta. Squaring and adding, we get k square into cos square s plus sin square s is equal to sin square theta plus cos square theta. So k square is equal to 1, or k is equal to plus or minus 1. So I hope this particular question you found it very interesting and were able to learn something new. Probably some of you might have been able to solve it also, because this was a little bit on the easier side. So thank you all once again for watching. Make sure you like, comment, subscribe to the channel, and hit the bell icon to never miss an update, and share also among your friends. And I'll see you all in the next one.